Ladies and gentlemen, welcome to the channel of Beyond Consultancy, where we discuss all things operations excellence. My name is Herman Lemmens. In this keynote, we will present two case studies. This keynote is the third of a series. In the first keynote, we explained the ABC analysis, and in the second keynote, we showed how to apply it. Let us continue. The ABC analysis is a method of classifying items, for instance products, according to their relative contribution to an overall objective, for instance sales. It typically creates three classes, A, B and C, for which specific operating policies can be designed. If done well, the sum of these policies supports the overall objective. The ABC analysis is often applied in product diversity studies. In the first case study, we will present the diversity improvements at a manufacturer of electronic modules supplied to the building services. These electronic modules are built around one or more printed circuit board assemblies, the so-called PCBAs. Technical innovations in the electronic parts lead to the design of modules with a better performance, which are then eagerly ordered and installed by the customers. These customers, however, also want the supplier to continue to take care of the older modules. The combination of these two forces results in an increase of the module diversity. If unchecked, this diversity will lead to higher operational costs. A regular module pruning is thus required to keep a balance between the costs and the benefits. A quantitative ABC analysis considers the following points. The electronic modules serve distinct applications X, Y, or Z. On average, the X modules run with high volumes but at a low price. The Z modules, on the other hand, have low volumes but are much more expensive. The Y application forms a category in between. Because of these differences, we need to make three separate ABC studies. As we have explained in the previous keynote, for each application area we determine the turnover per module, sort them in descending order, calculate the cumulative turnover, convert the values into percentages, plot the chart, and then classify the items into A, B, or C. A total of 36 electronic modules serve the application X. The first three modules cover 66% of the total turnover. More broadly speaking, the first 20% of the modules cover 90% of the turnover. This includes the A items and almost all of the B items. The C items form nearly 80% of the modules, but cover less than 10% of the turnover. On top of this, half of the C items did not even have demand. A total of 104 electronic modules serve Y. The first 5 modules cover half the total turnover, and more broadly speaking, the first 20% of the modules cover 90% of the turnover. This includes the A items and most of the B items. The C items form nearly 75% of the modules and cover only 5% of the turnover. Nearly half of the C items have zero demand. The ABC classification for Y is very similar to X. Lastly, a total of 34 electronic modules serve the application Z. The first three modules cover 53% of the total turnover. More broadly speaking here, the first 20% of the modules cover 85% of the turnover. This includes the A items and most of the B. The C items form nearly 75% and cover less than 10% of the turnover. Nearly half the C items have zero demand. The ABC curve for Z is somewhat less steep compared to the curves with X and for Y. This is because the rate of module innovation is slightly lower and the product life cycle somewhat longer. Nonetheless, all the three curves are at or above the 85-20 point, which for an ABC distribution is quite steep. The ABC analysis results in two main improvement areas. The first one concerns changing the production scheduling policy. All 8 items are scheduled as make-to-stock. This means that the customers experience the highest module availability and the shortest ordering lead times. The module supplier carries the risks and the costs of the parts and the modules inventories. All B items are scheduled as make to order. Their current finished goods stocks are gradually brought down to zero. The C items also move to make to order. However, they become prime candidates for pruning. We need to understand why an electronic module is a C item. We have to ask a number of questions. First of all, are we dealing with a newly released module? If so, the demand may still come. If not, can the module be phased out and can a last order be issued? Would there be any so-called legacy issues? Can the module be replaced by another, similar model? If none of these can be done, and in order to save cost, would outsourcing be an option? Perhaps it just may be the good time to increase the price of the module. This brings us to the close of the first case study. In a second case study, we will present the diversity improvements in the color master batch production for the residential textile industries. In the textile industry, fashion continuously requires the design of new color mixes, while at the same time the industry carries the obligation to be able to repeat the older colors. These color mixes are called master batches, or MB for short. These master batches are added to the extrusion process, coloring the extruded yarns. There should be a continuous diversity management in place to avoid an explosion in the number of current master batches. In the quantitative approach, we will make the ABC analysis of the tonnage of master batches produced. We will then add the life cycle data to come to a better understanding. For the period under analysis, we have 569 current master batches. These produced a total of 1,800 tons of color mix. 6% of the master batches produced exactly half of the total tonnage. They're called the A items. Inversely, the last 50% of the master batches only produced 6% of the total tonnage. They form the C items. The remaining 44% form the B items, and they produce 44% of the total. Note the perfect symmetry in this cumulative distribution. We will investigate this further on the next page. Half of the color mixes in the A class were designed during the last 6 years. At the same time, there are master batches which were introduced more than 12 years ago and still generate 5% of the A items. Some of the colors are very long living indeed. We note a slightly different but yet similar pattern in the C classes. Looking at the numbers, the 60% suggests that not all recently introduced colors became successful. The reason for the symmetry in the curve is mainly due to the gradual and even way colors move in and out of fashion. In close collaboration with marketing and design, a number of diversity reduction policies are introduced. One immediate action is to select a subset of master batches and to issue a last order. Another is to change the way of working regarding the introduction of new master batches. This new way of working is aptly called one in, one out. In order to accelerate the diversity reduction process for some of the colors, this would become one in, two out. Lastly, an investigation is started to see which master batches could be considered as standard and for which a more customer rewarding manufacturing and supply policy could be formulated. This brings us then to the close of the second case study. Some general observations regarding the ABC diversity analysis. It usually creates unexpected insights. It often reveals historic peculiarities about the company. It leads to very lively debates indeed, which by the end of the day result in a shared set of policy proposals. I would like to wish you all success. This then brings us to the close of this keynote. Thank you for being here. I hope you found it interesting. Please leave your views in the comment section below, and I hope to see you again.